Hey guys, we're going to do characteristics of quadratics. Again, these words you should have in your vocabulary. So just a real quick recap. Let me get my pen ready. Again, domain, x values, range, y values. When you're looking for the domain, remember you're going to look left and then right. Range is down and then up. Least to greatest, least to greatest. Vertex, remember, is your HK. We're going to see that several times. Axis of symmetry is going to be x equals whatever that h is. Okay, zeros, same thing as roots or solutions, all the same thing. X-intercepts, y-intercepts, mainly we're looking at x's and y, well, x-intercepts, y-intercepts because it crosses the x-axis, y-axis, etc. Remember the x-intercepts also tie into the zeros. Okay. X-intercepts, remember, could be 2, 1, or 0. Y-intercepts, there's always 1. Extrema is going to be the vertex. Remember, that's going to be a max or a min. Max as if it looks like a mountain. Min if it's a valley. Rate of change is going to be slope. We'll see that in a little bit. And intervals of increase is when we're increasing in value. Decrease is when we're going down in value. So, copy the first example here. Okay, again, you can pause the video, hit all the major points. The equation is negative x squared plus 9. You know, we have a point up here, it's 0, 9. Point down here, negative 3, 0. If this helps you out when you graph, the point down here is going to be 3, 0. So, graph that real quick, or pause it and graph it, so you can take notes on it. This might help. This is 1, 8. And this is going to be negative 1, 8. Again, this helps with the graph. So, now that you got a graph, vertex, easy, 0, 9. Axis of symmetry, remember, it's the x value here. Domain, remember, we got to think abstract. How far left is this going? How far right? These are x values. So, speaking abstractly, this graph will go on forever. Okay? So there's always going to be an x value. When you go left, there'll always be a x value when you go right. So it's going to be negative infinity to infinity, or all real solutions, all real numbers. See if I can do that a little better. There we go, that looks better. Or sometimes you'll see written as this. Okay. Range, on the other hand, how low can you go? How high do you get? These are y's. Well, it's going to go down forever, negative infinity. But on the upside, though, it stops at 9 and it's going to be inclusive. Okay? We need to put a bracket right here, square bracket. We're including the 9. The infinity has a parentheses because we're approaching infinity. We'll never get there because it's infinity. X-intercept crosses the x-axis. These are points, so negative 3, 0. Again, these are points, so they need to be written as coordinate points with an x and a 0. I mean, x and a 0. An x and a y. Now the zeros, remember, come from the x-intercepts. So fancy bracket negative 3, fancy bracket. Now, I know we got 3 different little bracket parentheses things. You got to be able to tell where the difference is. Oh, in fact, range, I need to go back up here. We want 9, but we want everything less than 9, but it can equal 9, and that's how you do that as an inequality. But back here, y-intercepts, it's going to be 0, 9. Crosses the the y-intercept right up here, y-axis up there. This has a max because it looks like a mountain. It's going to be at the vertex. Intervals of increase. Again, think of it like someone is on a mountain. Okay? They're going left to right. They're going to be climbing uphill this way, but then going downhill this way. These are x values, so you got to look at the x-axis for this. So they are going to be increasing from the negative infinity side all the way to 0, okay, 0, because once you get to the top, you start to go down. So to 0. And then since they started going down to the 0, well then it's going to be 0 to infinity, because that's when they're going downhill, decreasing. I think the guy on the mountain is the best way to figure out the increase and decrease, but just like a book, left to right, when are you going uphill, when are you going downhill? All right. Rate of change. Remember, that's the slope idea. Slope is rise over run. The formula from last year is x2 minus x1, excuse me, y2 minus y1, x2 minus x1. But we need points. This 2 is an x and this 3 is an x. So, I don't know where to put this. Put it down here. When x is 2, you can look at the graph here, it should be 5. And when 3, well, 3 is 0. And notice, if we wanted to, we could plug it into the equation and get the same thing. Okay. In fact, keep these points in mind because we're going to come back to them shortly. But now that we got our values, remember, this could be x1, this could be y1, this will be x2, and this will be y2. So 0 minus 5 all over 3 minus 2. 0 minus 5 is negative 5. 3 minus 2 is 1. So our answer is negative 5. Now, that's using the points. If we have the graph here, watch this. We could count it. It is rise over run. We went down 5. And since we went down, it's a negative 5. And we ran 1. So rise over run. Rise over run. And we get the negative 5. Either way is fine. Whatever floats your boat. But for the sake of keeping a short video, I'm just going to count these. So again, pause the video if need be so you can graph it. All right, this will be my next example. Then moving on to greater and better things. Vertex. We got it right down here. 3, negative 4. And if you look at this, it's in vertex form. You should have been able to pull the 3 out of this and the negative 4. So 3, negative 4. Remember, opposites in parentheses right here. Let me erase all that. Boop. So, axis of symmetry, you already know. It goes on forever, all real numbers. This one opens up, so its lowest value is going to be negative 4. Bracket negative 4. It's going up, so to infinity. X-intercepts, we have 1, 0 here, and 5, 0. zeros, again, you could write it like this. Or if you want to be fancy, whatever floats your boat. Y-intercept. Scroll up and see that one. I'm going to give that a 0.5 up here. So 0.5. Again, you could plug in a 0 to find your y-intercepts. Pretty much for any function out there. Max and min. This is a valley looking shape. So it's going to be min, and we put the vertex, which was 3, -4. This time, the man is going, oh boy, trying to draw a man, maybe. He's going downhill here, and when he gets to this side, he's going uphill. So, intervals of increase is going to be, again, look at your x values, 3 to infinity, decreasing, -infinity to 3. Again, for the sake of time, 2 to 3, that's going to be right here to right here. I went down 1 to the right 1, so -1. Rise over run. Again, rise over run, just in case you didn't know where I got the -1 from. Boop. I think we can fly through this real quick. Again, pause the video so you can graph your equation, or graph. Okay. So, vertex, 1, 3. Again, opposite. Axis of symmetry, x equals 1. Domain, again, all real values. Range, it went as low as 3. So bracket 3 is going up, so infinity. X-intercept, there is none. Does not cross the x-axis, which means there's no zeros or no real solutions. Again, because it doesn't touch the x-axis. Y-intercept, though, we got one right there. 0, 5. Again, x is first, and then y is alphabetical order. Since it looks like a valley, there is a minimum. Again, it's at the vertex. Intervals of increase, it's opening up, so this bad boy is going to be 1 to infinity for increasing. See, going uphill. And then downhill would be -infinity to 1. Okay, you know, right here, axis of symmetry is when it change directions. 1 to 2. Let's see, 1 to 2. Let me erase this gibberish so we can see here. So we got 1, see, 1 to 2. So 1, 2, we went up 2 to the right 1. So 2 over 1 is 2. Rate of change here is going to be 2. Easy peasy. I think that's about it. Yeah, we're done with that. Alright, let's chase another idea here. We're going to need to write this down. In behavior. Wow, can't believe I just did that. Just trying to underline it. Boop, boop, boop. In behavior tells us what the y values of a graph are doing as x values approach positive infinity and negative infinity. In your own words, describe the in behavior of the quadratic function with positive leading coefficient. Hint, make a picture. Excuse me, had a cough. So, draw a picture. Draw this bad boy. Notice the infinity symbols. Again, x-axis, y-axis. As x approaches infinity, okay, right here, as we're moving right, what is the y doing? It's going up to infinity. So, as x goes to negative infinity, again, what are the y values doing? Going up to infinity. That's right. You're going to learn when it opens up, Both of these answers are going to be positive infinity, which means if it's opening downwards, that's right, they'd both be negative infinity. I gotta get some water. So take this note. I think I got a slide for you. Let's see if we can find it. It's in here. This is just me recapping domain. Again, all real numbers for mostly. Even when it's negative, still all real numbers. Range, we discuss how, low, high, greater than. Here comes an important thing. You should be. Oh, man, I gotta get some water. I'll be right back. Oh, that's better. Of course, I was gone for a couple minutes, but I'll pause the video so you didn't know the difference. Anyway, let's talk about this one real quick. It says, where is the vertex for the graph of this function? Like I said in class, you should be able to look at an equation and tell me most of these things. For example, this vertex should be 1, 4. Again, opposite, and you just keep the same sign there. Does the parabola open up or down? This is a positive leading coefficient. There's no negative, so this thing is going to open up. Is the vertex the highest point or the lowest point? Since it's opening up, here's a quick picture. The vertex is going to be the lowest point. The min. Okay, 1, 4. Now, since it's the minimum, what's the range going to be? Well, 4 is going to be the minimum here. And then it's going to be bracket 4 raised to infinity. Again, range. Please don't confuse this R with the double backbone R. All right, let's go to some examples real quick. Boop. All right. Notice the things that changed. Go ahead and pause the video and try it for yourself. All right. So let's take care of the vertex. -1, -4. Okay. Negative leading coefficient, which means it opens down. So our vertex is right here, -1, -4. Since it opens down, that means our range is going to be negative infinity. And the highest point is right here because it's a max. So net range, remember y values, -4, bracket. Okay. And yeah, again, this is one way you can write it, but we got the right thing. Should be able to tell me the domain and range for each of the following. So go ahead, pause the video and try these out. All right. Easiest way to think about these is one, get the vertex and see if it opens up or down. So for this one, this is a parent function. So it's going to open up. That's the lowest point. Vertex is 0, 0. So the range for this one, again, I'm going to write in intervals, is going to be bracket 0 raised to infinity. This one, again, no negative, so it opens up. Okay, its vertex is going to be 4, 3. So the 3 is the minimum, or, the lowest part of the range, bracket, raised to infinity, because it opens up. We got a negative, so this thing opens down. So now the vertex is the highest, maximum, and that's -1, -4. So negative infinity to that -4. So bracket for that, parentheses. Again, this one opens up. Range here, or the vertex here, is going to be 6, -13. That's a -13. So -13 is the lowest, and it opens up, so to infinity. Again, opens down. I'm telling you, once you get this opening down and up, it solves all your problems. 613, since it's opening down, negative infinity to 13. Put a bracket around it. Fun fact, 613 is my birthday. Yeah, happy birthday me. Opens down because of the negative. Vertex, -3, -5. So that means negative infinity for the range to -5. Now, you're wondering, you skipped all the domains. All you did were range. That's right. But let's face it, I'm not restricting the domain. So the domain for all of these is going to be all real solutions. Okay? As you can see, we got them all right. In behavior, I think this is what I wanted to show you. Let's see. Well, it's usually written as these two statements. As x approaches negative infinity, f of x approaches whatever, infinity, whatever. Again, your only options are going to be negative infinity or positive. Again, they're both going to be negative infinity in this class, or they're both going to be positive infinity. Again, if it opens up, and this is if it opens down. Boop. Here's the slide I was waiting for. Only two possibilities. If you want, go ahead and freeze the screen so you can copy the positive leading coefficient and what it looks like. Negative leading coefficient, again, when it opens down. You can just freehand this and pause the video. Alright, let's keep going. Describe the behavior for each of the following. So, as x approaches negative infinity, just looking at this, it's opening upward, positive leading coefficient. So that means f of x, or y, whichever way you want to look at it, is going to be to infinity. And just like we discussed a second ago, the other one should be the same thing. This one's negative, so that means it opens down. So as x approaches negative infinity, f of x, or y, approaches negative infinity, because it's going down. And then same thing for the other way. Easy peasy. I think in class I was talking about that idea of approaching. Again, if you didn't copy that last slide, here it is again. I think you're going to hear about absolute maximum next year because there'll be two different types of maximum. But, for our sake, we're just saying maximum, but this is going to be the absolute because it's the highest point. Okay? Which means there's an absolute minimum, same thing. Yeah, I'm just going to be using maximum and minimum in class, but yeah, there is such thing as an absolute maximum, absolute minimum, and there's another max and min out there, but I won't bore you with that, but that'll be in advanced algebra. Boop. Oh, and since we're in this class, it's only going to be one or the other. Back to intercept coordinates points. We won't get into that. Reminder, this is a good example on why there's only one y-intercept. Okay, there's always going to be one y-intercept. If you want to take your notes for that. X-intercepts, remember, chasing that idea of there's one here, 0 here, because it doesn't cross the x-axis, and we have 2 here. Okay. Boop. Zeros functions where it crosses the x-axis. Yeah, we discussed that. Examples. I've already posted the answer for this. Alright, trying to keep this short. So, see you later.